So your num
Is equal to num
and this will be in
while num is greater than
while none, and then you return.
But here is the thing. What happens when you have zeros here?
Good question. So how will you do that? Okay, so what you can do is, before you return, you'll be returning return answer. You have to find out the number of bits in num. You have to take a counter, keep reducing every time you have done this, and then left shift the result by the number that is left. So you will have something like int s equal to size of num into size of char minus 1. You are reducing this s, meaning you know what is the total size of or the length of the number irrespective of the zeros and ones. Then you are actually putting some value into the answer. At some point in time your number will become 0 but not necessarily s. So what you will do is you will say answer is left shifted by s, and then you return it. Make sense? This is done because your integer size can differ based on compilers. So you want to make your code not hard coded to one particular compiler. It's always good to have variables every time you take some hard coded value, because 5 years down the line if somebody looks at your code, he'll be like, why is there a 4 here? Everybody aware of Little Indian, Big Indian? Okay. So depending on the position of your MSB and LSB, you define what is Little Indian and what is Big Indian. If you have this particular situation, this is called Little Indian, not Indian from India. And this is your Big Indian. The difference is, if you were to be representing, let's say 8, over here it will be represented as this, over here it will be represented like this also. Some embedded systems use this. I don't know why. They do. This is the easiest to understand because here the value is descending, here it is ascending. We have to write a piece of code that returns true when it is little endian and false when it's big endian.
So how will you get to know?
Think?
No, it could be a little endian or big endian.
Yeah, so you write a function that will return true when your machine is little endian, it returns false when your machine is big endian.
So will it tell that this was a number? So like it could be like
So the question I
it
think
could be
is,
1, it
so
could be 10.
No, this is 8. This is 8. Okay?
Yeah, so we are aware that we are checking the 8.
Yes.
Okay.
This is an example. I will not use this value. But think. The signature will look something like bool is Indian.
Pass the integer and just get the AND of with the 1 and give the LSB is
So you are, remember, you are ANDing it with 1. Your MSB, it will always return what? Because if in big Indian your 1 is represented as, because you are again relying on another integer. I'll give you a hint. Yes, that's one way to do it. That's one way to do it, but this is an elegant way. You have something called union. I swear to God, till the time I read this, I had no idea what union is. The union is just like a structure. You can define whatever you want, int, char, int, char. The difference between a union and a structure is whatever components the union has inside it, they take the same space on the compiler. Over here, everybody's assigned individual space. Over here, the int and the char share the same space. That's the hint. Exactly what you said. If I were to say something dot the integer equal to 1, if it is a big Indian, this is how it will be. If it's a little Indian, this is how it will be. If I wanted to typecast this as a character, the compiler is going to take only this part. Do you see the difference? You just return
Okay, so
Just a question on that one.
Anj.
If you have to do that one in C#, is it possible?
This is possible anywhere, right? Union is a data structure. You should have this data structure anywhere.
How about Java?
Java also,
It doesn't have union.
Java, I don't know.
Then you can type.
Java, you can typecast.
Typecast.
Just use a typecast. So just say integer and assign the value 1 and typecast it to char.
It will return star value.
Typecast might change it. Might. I don't know. I don't know about Java, honestly. This should work in C++ and C#.
C++ for sure.
okay, so we have a few minutes, and the next class is linked list. So like, I'll just start with the linked list. Just give the basics of linked list. And today is just a basic, very very easy, not as difficult as he thought. So, and we will. Okay. And I saw that last night. My bar spot actually shows up over there. So, anyways, okay. So yes, so linked list. What like there are a lot of questions that are being asked for linked list. Like when I was at Microsoft, when I gave the Microsoft interview, they asked me a question. At Amazon also they asked me a question. So I'm assuming that a lot of people ask questions about linked list, and it's easy and. Like what I want you guys to do is waste a little bit of time. So for every linked list question or something, if they ask you, draw make a class of linked list. What this will do is this will actually show the interviewer that you know what a class is, you know constructor, destructor, and all this other stuff, and then you write your program and stuff. So that will actually help you, and it will waste your time also. Like it will waste a little bit. Okay, so where's my paper? Okay, so linked list is and also ask your interviewer that what kind of linked list is it? It's a single linked list or a double linked list or a circular linked list. I mean, like there are a lot of different things. It's always better to ask that. So, but generally. It is always a single linked list because that causes a lot of problems, and you have to deal with pointers and stuff like that. So that is always better. So linked list is a structure like this, where yes.
So what is more common? Like you get direct questions on linked list, or you get
you might get a direct yes. So I'll start today. I'll start with just the basic. I'll write a class, I'll write a constructor, I'll write a destructor, I'll add a head, add a tail, get the length, and all this other things. From on the next class, we will actually do a circular linked list, and we'll figure out the starting point of the circular linked list, and then we'll do a sorted insert, and then we'll merge through the linked list. We'll do a whole bunch of
Will
things.
you skip list as well?
Excuse me.
Skip list or will you?
Sure, we'll do skip list also. Whatever you want. We'll do everything. Yes. So linked list is my favorite. So yes. Okay. So linked list is a structure like this in which you store some data. So for now we'll assume that we are storing an integer. So let's say 2, 5, 7 or something like that. There will be a head, which is the starting point of the linked list, and the tail actually will point to null. This is a simple structure, and so basically you can write a class for this node also. So if you think about it, a node has data and it is pointing to another node, right? So you can make a class or you can make a structure. I'll just make a structure. So I'll struct a list node. The list node will have an integer data and a pointer to the next one. So it will have a list node star next. and I'm doing in C++, so it is easily portable to C#. Okay, so that will be the structure of the node, and I'll start writing the class now. So in a class, what you do is you write class a link list, and you will have a public and a private section. A public section will have a constructor, a link list, and a tilde a link list. The destructor will call a function. That is how I do. Like, it will call a function void delete list. So delete list will delete the entire list. Okay. And yes, then you can stop me wherever if you don't understand. In the private section, I will write the structure. So I'll write a struct a list node, and the node will have integer data, and a list node star next. So this is the structure, and you will have a head, because you need a starting point. So we will write a list node star head. So this will be the head of the linked list, right? Now we'll start writing the function. We'll slowly build up this.
We have a tail.
Huh?
Tail, we need a tail.
Do we need a what? Tail?
Tail.
Do you? The tail will point to null. You can. I will.
If they're going to adding at the end, then did you have to go
Yes.
forward to the end?
Yes.
adding?
We will do modifications. So I